take a look at a thing called Descartes' rule of signs and how it can tell us how many positive real roots this equation could have and how many negative real roots this equation could have. So let's start with the positive. I'm going to look at the polynomial function p of x equals x cubed minus x squared plus 1. And Descartes' rule of signs looks at the sign changes in this function, and it counts them up. So again, I just took this and wrote it in function notation instead of equals 0, and I'm going to look from term to term. Here I have a positive x cubed to a negative x squared. That's one sign change. And then I go from a negative x squared to a positive 1. That's another sign change. So this right here has two sign changes. So what that means is that there could be two positive real zeros or 0. It's a lot like back when we talked about the turning points of a function. If a function had a maximum of 4 turning points, it could also have 4 or 2 or 0. If it had 3, it could have 3 or 1. They decrease in even pairs, even by even numbers like that. So Descartes' rule of signs showing two sign changes here for the positive tells us that there could be 2 positive real zeros or 0 positive real zeros. It's not exact. It just narrows it down. There's either 2 or there's none for this particular one. Now we also need to look at the negatives. So what we do is we take p of negative x. In this case, we replace all of the x's with negative x. So I'm going to go ahead and rewrite this. Instead of as x cubed, I'm going to put negative x in parentheses cubed minus negative x squared plus 1. And then I'm going to simplify that a bit. If I take a negative and I cube it, I get a negative. So that's just going to give me negative x cubed. If I take a negative and then square it, that's going to be positive, but then I still have this minus sign out in front. So that will be minus x squared and then plus 1. So now that I've figured out what p of negative x is, now let's look at the sign changes. I go from negative to negative. There's no sign change there. And then here I go from negative to positive. There's one sign change for this one. So one sign change means that there is one negative real zero. We don't know what it is, we just know there has to be one of them, and that's kind of powerful. If there had been 5 sign changes, then maybe that would have told us that there could have been 5 or 3 or 1. Like that. Again, it's just telling us how many there could be. It's not telling us any information about what they actually are. So that's how you use Descartes' rule of signs. Take a look at the original, count up the sign changes. That'll tell you how many positive real zeros there could be. Decrease that by even numbers to figure out how many options there are. And then to figure out the negative ones, that's the ones where students usually have a little bit of trouble. You replace x with negative x and you simplify. Long story short, what that does is that changes the sign of any term in the original that had an odd exponent. Anything that had an even exponent will have the exact same sign that it did in the original p of x for that. So that might help with that a little bit. And then again, look at the sign changes after you've done all that, replacing x with negative x. Count up your sign changes. That'll tell you what the maximum number of negative real zeros could be. And then again, decrease them by even numbers to give you your other options. I hope that helps.